Welcome to Spring LIB.
In this problem, we're talking about the cardinality of sets. And this is a very interesting topic because essentially we're now learning that there are different kinds of infinity. We can see that there's uncountable, there's countable, there are different sizes of infinity, and that's really interesting to analyze. So specifically in this problem, we are looking at various sets and deciding if they're countably infinite, if they're finite, or if they're uncountable. So for part A, we have the set of negative integers, which I noted as z minus. So something that we should know is that any subset of z of the integers is countable. So we know that z minus, the negative integers, is definitely a subset of the integers. So this set is countably infinite. Now on to part B, we're given, let's denote set A of the even integers. And we can say that it's 2z because remember, 2 times an integer would be an even integer. And we can say that 2z is definitely a subset of z. So the even integers is a subset of the integers. So we can say that the set of even integers, set A, is countably infinite. Now on to part C, we're given the set A of integers less than 100. Again, this is a subset of z, so this is countably infinite. Now on to part D. This one's a little bit more confusing. This is a set, which will denote A, of all the real numbers in between 0 and 1/2. Well, the real numbers is an uncountable set. So any subset of an uncountable set, being the reals, is uncountable. So set A of the numbers between 0 and 1/2 is uncountable. For part E, we're given set A of the positive integer z plus less than 1 billion. This is a finite set. This might be a little bit confusing because we said earlier that any subset of the integers is infinitely countable, countably infinite. In this case, though, we're given the positive integers, and if you think about that for just a second, of the positive integers, those are definitely countable. So this is going to be a finite set. And lastly, for part F, we're given that we have to investigate the multiples of 7 of the integers. So we can say we'll denote that as as 7z. So we can clearly see that this is a subset of z. So the multiples of 7 of the integers is definitely a countably infinite set. So I hope that this problem helped you understand cardinality, maybe even introduced you to the concepts such as countably infinite, finite, or uncountable sets. And this is a really interesting discussion because we get to learn now that there are different sizes of infinity.